Engines are the heart of every car, but what happens when that heart fails miserably? Today, we're counting down the 10 worst engines of all time. From catastrophic design flaws to notorious reliability issues, these engines have left drivers stranded, frustrated, and out of pocket. So buckle up for a wild ride through some of the biggest engineering blunders in automotive history. Engine number 10, BMW N63. The BMW N63 is a 4.4-liter twin-turbocharged V8 engine that debuted in 2008. Its innovative hot V design places the turbochargers inside the V of the engine, enhancing throttle response and reducing turbo lag. Initially producing 402 horsepower and 443 pound-feet of torque, the engine's power increased in later versions, with the top variant delivering up to 523 horsepower and 553 pound-feet of torque. Despite its performance, the N63 is notorious for several reliability issues. Oil consumption. Early models suffer from excessive oil consumption, necessitating frequent top-ups. Turbocharger failure. High temperatures in the hot V configuration lead to premature turbocharger failures. Timing chain stretch. The timing chain stretches over time, risking severe engine damage if not addressed. High-pressure fuel pump failures. HPFP failures can leave drivers stranded. Valve stem seals. Degradation of these seals leads to oil leaks and exhaust smoke. Engine number 9, Hyundai Theta 2. The Hyundai Theta 2 engine family, in production since 2004, includes several 4-cylinder gasoline engines known for their performance and efficiency. Available in 2.0-liter and 2.4-liter variants, these engines feature an aluminum block and head, with power outputs ranging from 143 horsepower to 271 horsepower and torque from 140 pound-feet to 269 pound-feet. The Theta 2 engines incorporate advanced technologies such as variable valve timing and direct fuel injection for improved efficiency and performance. Despite their advanced features, the Theta 2 engines have been plagued by several reliability issues. Oil sludge and engine seizures. The 2.0L and 2.4L GDI variants are prone to oil sludge buildup, leading to oil starvation and engine failure. Bearing failures, premature bearing, wear causes, knocking noises, and eventual engine failure. Noisy operation, increased engine noise during cold starts, often due to the high-pressure fuel injection system and timing chain tensioners. Engine number 8, Oldsmobile Diesel. The Oldsmobile Diesel engines, produced by General Motors from 1978 to 1985, were a series of V6 and V8 diesel engines based on the Olds 350 gasoline engine architecture. These engines were introduced to improve fuel economy in response to the 1970s oil crisis. However, they quickly became known for their numerous design flaws and reliability issues. The Oldsmobile diesel engines suffered from several critical problems. Head bolt failures. The initial design included weak head bolts that couldn't handle the higher compression ratios of diesel engines, leading to head gasket failures and severe engine damage. Water separator issues. The engines lacked effective water separators, causing water contamination in the fuel system and damage to rubber components when owners added alcohol to prevent freezing. Poor conversion from gasoline engines. The engines were essentially modified versions of gasoline engines, without sufficient redesign to handle diesel stresses, leading to mechanical failures such as broken crankshafts and premature wear of internal components. Engine number 7, BMW N57. The BMW N57 is a series of 3.0-liter inline 6-turbo diesel engines produced from 2008 to 2020. Known for its performance and advanced technology, the N57 was designed to replace the M57 engine. It features an aluminum cylinder block, twin camshafts, and common rail direct injection. Power output ranges from 204 horsepower to 381 horsepower, with torque figures between 332 pound-feet and 546 pound-feet. The N57 engine is plagued by several reliability issues. Timing chain failure, premature timing. Chain failure is a significant issue, leading to catastrophic engine damage if not addressed. High-pressure fuel pump failure. The HPFP can fail due to injector pump leaks and poor quality fuel, causing poor acceleration and engine stalling. EGR valve clogging. The EGR valve can clog, reducing engine efficiency and performance. Turbocharger failures. High-mileage engines often experience turbocharger failures due to worn bearings. Diesel particulate filter issues. The DPF can become clogged, especially in vehicles used for short trips, leading to reduced power and excess smoke. Engine number 6, Chevrolet 2300 Vega engine. The Chevrolet 2300, commonly known as the Vega engine, is a 2.3-liter inline-4 engine produced from 1971 to 1977. Designed specifically for the Chevrolet Vega, this engine aimed to compete with small, fuel-efficient imports. The Vega engine featured an innovative aluminum block with a sleeveless design, which reduced weight and manufacturing costs. The Vega engine faced several critical issues that impacted its reliability. Overheating. The open deck design made the engine prone to overheating, causing cylinder warping and head gasket failures. Oil pressure problems. The engine's oil pressure switch would shut off the engine if oil pressure dropped too low, highlighting its tendency for oil-related issues. Durability. The aluminum block was prone to premature wear and scuffing, particularly if not maintained properly. Later versions saw some improvements, but the damage to its reputation was already done. Engine number 5, BMW N47. The BMW N47 is a 2.0-liter inline-4 turbo diesel engine produced from 2007 to 2014. Known for its performance and efficiency, it features common rail direct injection and turbocharging, with power outputs ranging from 114 horsepower to 218 horsepower in torque, between 192 pound-feet and 332 pound-feet. The N47 engine is infamous for several reliability issues. Timing chain failure. Premature timing chain failure can lead to catastrophic engine damage, particularly in engines produced between 2007 and 2011. Crankshaft pulley failure. The crankshaft pulley can fail around 80,000 miles, affecting the accessory belt and potentially causing extensive damage. DPF issues. DPF problems are common, especially in vehicles used for short trips, leading to reduced power and increased emissions. EGR valve problems. The EGR system can clog with soot, reducing engine performance and posing a fire risk. Oil leaks. Frequent leaks from the oil filter, housing gasket, and oil cooler gasket can lead to oil and coolant contamination. Engine number 4, BMW S65. The BMW S65 is a naturally aspirated 4.0-liter V8 engine produced from 2007 to 2013. It powered the E90, E92, and E93 and M3 models and was celebrated for its high-revving nature and impressive power output. The S65 features individual throttle bodies, double VANOS variable valve timing, and a redline of 8,400 RPM, producing 414 horsepower and 295 pound-feet of torque. Despite its accolades, the S65 engine faced several reliability issues. Rod bearing wear. Premature wear of rod bearings can lead to engine failure if not addressed. Regular inspection and replacement are recommended. Throttling actuator failure. Throttling actuators can fail, causing the engine to go into limp mode. Replacement is the typical remedy. Oil consumption. Some engines experience higher than expected oil consumption, requiring more frequent top-ups. Engine number 3, Ford 3.88L Essex V6. The Ford 3.8-liter Essex V6 is a 90-degree V6 engine produced from 1982 to 2008. It was designed to replace older inline-6 engines and provide a balance of performance and efficiency. The Essex V6 featured a cast-iron block, aluminum heads in various iterations that included carbureted and fuel-injected versions, with power outputs ranging from 110 horsepower to 230 horsepower in the supercharged versions. The Essex V6 faced several reliability issues. Head gasket failures. The most notorious problem, due to differing expansion rates of the cast iron block and aluminum heads, leading to coolant leaks and overheating. Oil leaks. Frequent oil leaks from valve cover gaskets and intake manifold gaskets. Timing cover leaks. The timing cover gasket could fail, leading to coolant and oil leaks. Engine number 2, Chrysler 2.7L V6. The Chrysler 2.7-liter V6 engine, produced from 1998 to 2010, is known for its dual overhead camshaft design and 24-valve configuration. This aluminum block engine offered power outputs of 190 horsepower and 190 pound-feet of torque, aiming to provide a balance of performance and efficiency for mid-size cars. The 2.7L V6 engine is notorious for several significant reliability issues. Oil sludge buildup. One of the most severe problems, leading to clogged oil passages, reduced lubrication, and catastrophic engine failure. This issue was exacerbated by infrequent oil changes and poor quality oil. Water pump failure. The water pump, driven by the timing chain, could leak coolant into the oil, contributing to sludge buildup and engine damage. Head gasket failures. Due to differing thermal expansion rates of the aluminum head and steel sleeves, head gaskets often failed, leading to coolant leaks and overheating. Engine number 1. Ford 1.0L EcoBoost. The Ford 1.0-liter EcoBoost is a turbocharged 3-cylinder engine introduced in 2012. Known for its compact size and impressive performance, the engine features a cast iron block, aluminum head, and advanced technologies such as direct fuel injection, variable valve timing, and an integrated exhaust manifold. Power outputs range from 100 to 140 horsepower, with torque between 125 and 200 pound-feet. Despite its innovative design, the 1.0 EcoBoost engine has faced several significant reliability issues. Coolant leaks. Early models experienced problems with coolant hose failures, leading to potential engine overheating. Carbon buildup. The direct injection system can cause carbon buildup on intake valves, affecting performance over time. Fuel pressure problems. High-mileage engines may suffer from reduced fuel pressure, impacting performance. Timing belt maintenance. The timing belt runs in oil and requires periodic replacement to prevent failures.